In section 3.4, we're trying to graph a polynomial function. We're going to use the following steps to do it. We're going to find the x-intercepts, the y-intercept, the end behavior. We're going to make a sign diagram, and then we're going to put all that together to sketch the graph. The only thing that we haven't talked about yet is the behavior at the x-intercept. It could be a cross, a bounce, or a wiggle. What it is depends on the multiplicity of the zero. And so the most common behavior is called a cross, and I have an example drawn here in red where you see the graph. The graph of a polynomial is a smooth curve, and you see that smooth curve just pass through the x-intercept and continue on the other side. And actually here's another cross at the next x-intercept. The second possibility is a bounce, and this time the graph approaches the x-intercept, but then instead of continuing on the other side, it turns and goes back up. It stays on the same side it was on before. It doesn't have to be above on both sides of the x-intercept. It could be below on either side of the x-intercept. And then the third possibility is a wiggle, and in this case we see the graph, we see the curve approaching the x-intercept, and it looks like it's going to be a bounce, but then it continues on to the other side. So we'll learn to call this an inflection point in calculus class, but for today, wiggle is good enough. We associate a wiggle with x to the third power. That's a 0 of multiplicity 3. And we associate the bounce with x to the second power, which is, of course, a 0 of multiplicity 2. Okay, we'll see that again in a few minutes in an example. For now, let's go on and let's try to graph this polynomial. It's x cubed minus 7x minus 6. I think it's worth pointing out that we already know how to graph the function y equals x squared minus 7x minus 6. We learned that in section 3.1. And we already know how to graph y equals x cubed minus 6. We learned how to graph that in chapter 2. So the new function is similar to these others that we've studied before, but it's also significantly more complicated than these others. And so the 5-step process outlined above will help us get through it. The first step is to find the x-intercepts. Remember, these are also called zeros. The only difference is that 0 could be a non-real number, and an x-intercept has to be real. How do you find x-intercepts? You set y equal to 0 and solve for x. And so the equation we want to solve is x cubed minus 7x minus 6 is equal to 0. And so how are we going to do that? Well, that was the big question in section 3.3. What we learned is that we can find possible rational zeros. And then we can check whether or not they're zeros using synthetic division, and we can factor the polynomial from there. So the possible rational zeros would be factors of 6 divided by factors of 1. Since the denominator is only 1, then the possible rational zeros would be factors of 6. They would be either 1 and 6 or 2 and 3. And remember, we put a plus or minus on each of these. And then we can just start checking. And we can check these possible zeros until we find one that works. And then when we do that, when we find one that works, then not only do we have a 0, but we also but we also have a factored form of the cubic. So let's check x equals 1 with synthetic division, 1 outside, and then the coefficients on the cubic. 1x to the third. X squared is missing, so we'll put in a coefficient of 0 for that. And then -7, and then -6. And then we'll go through the synthetic division and see how it comes out. Oh, it's not going to work. The remainder is -12. So we'll have to try again with the next value. Maybe we'll try x equals -1 next. So if we plug in -1, and then we have 1, 0, -7, and 6, 1, -1, and so on through the synthetic division. And I think it's going to work. There was a negative sign on the 6 here at the top, and then there's a +6 right below it, so the remainder is 0. And so sure enough, we found a 0. And then not only did we find a 0, but again, we can use the synthetic division to get a factored form of the cubic. So now we're going to write the cubic as x plus 1 multiplied by the quotient, which is x squared minus x minus 6. And then we can factor the quadratic. And then we can set each of those factors equal to 0 to get our x-intercepts. -1, 3, and -2. It might be nice if we wrote these as ordered pairs, especially since we're going to graph them in a few minutes. And then the other thing that would be nice would be to describe the behavior. Since each of these factors is raised to the power of 1, x plus 1 to the first, x minus 3 to the first, x plus 2 to the first, all three x-intercepts represent a cross when we're describing the behavior at the x-intercept. So we can go ahead and box that up, and we can go on to the next step. So step 2 was to find the y-intercept. And so the y-intercept is just setting x equal to 0. And let's see, our function that we're working on is f of x equals x cubed minus 7x minus 6. So let's not forget that. And so the y-intercept will be 0 cubed minus 7 times 0 minus 6, or -6. And so we can go ahead and write 0, -6, and box that up. We need to describe the end behavior. And remember, the end behavior is described by the leading term, which is y equals x cubed. And so y equals x cubed goes down to the left and up to the right. And then we need to find a sign diagram. We haven't done this maybe since chapter 1. Do you remember what they look like? We're trying to test the sign of the function on different intervals. And so the intervals are determined by the x-intercepts. And then we'll take a test value on each interval, and we'll check for the sign of f of x. And then that will tell us if the graph is above or below the x-intercept. We have 3 x-intercepts, so we're going to have 4 intervals to check. We're going to check across the entire domain of the polynomial, which is all real numbers. We're going to start from negative infinity, and we're going to go up to the first x-intercept, which is at negative 2. And then we're going to go from negative 2 to the next x-intercept at negative 1, and then negative 1 to 3, and then 3 to infinity. Test values on each of those intervals: negative 3, negative 1.5, 0, and 4 would work. And then when we want the sign of f of x, let's use the factored form of f of x. So f of x is the same as x plus 1 times x minus 3 times x plus 2. And so using that factored form here, we're going to plug negative 3 into each factor and see what the sign is. Negative 3 plus 1 is a negative number. So we can just write a negative. Multiplied by negative 3 minus 3 is another negative. Multiplied by negative 3 plus 2 is another negative. And so then that gives us a negative. Here, maybe it's nice to just go ahead and write out neg for negative. And of course, if the function values, if the y values are negative, then we're below the x-axis. And then we can keep doing this with the remaining test values. So negative 1.5 plugged in is going to make a negative multiplied by a negative multiplied by a positive. And that will give us a positive result. That means the graph is above the x-axis. 0. 0 plus 1 is positive. 0 minus 3 is negative. 0 plus 2 is positive. So the result is going to be negative. And we're back below the x-axis. And then 4 is going to give us a positive times a positive times a positive, which is going to give us a positive result. We're above the x-axis. If you remember that the graph is going to cross the x-axis at negative 2, then that means that the sign has to change at negative 2. So if it was below before, it would have to be above after. And the same thing at negative 1 and 3. Since the behavior at the x-intercept is a cross, then the sign has to change from positive to negative or negative to positive. And so the graph has to change, being above or below the x-axis. Okay. Well, we can go ahead and put all this together to make the graph. And so I'm going to start with some axes here. And I want to plot the x-intercepts first. I want an x-intercept at 3. And another one at negative 1. And another one at negative 2. Okay. And I could go ahead and plot the y-intercept at -6, although maybe I'll wait for that. I can go ahead and start the end behavior and draw the graph from there. End behavior says that at the left end of the graph is going down. And that agrees with our sign diagram as well, which says that the graph is below the x-axis. And then if we go from left to right, what does this graph do? This graph comes right up through, crosses over the x-axis, comes right up through -2, crosses over the x-axis, and then what does it do? Then it has to turn and come back down so it can catch the next x-intercept at -1. So above the x-axis only briefly, and then back down to cross over the x-axis at the next x-intercept at -1. Notice from -2 to -1, we're above the x-axis, and that's what the graph shows. And then from -1 to 3, we're going to be below again. We're going to be below the x-axis. We're going to come through the y-intercept, and then we're going to turn and we're going to head back up. We're going to cross at x equals 3 and continue on up, going up to positive infinity above the x-axis to the right of 3. We can come back and we can label the y-intercept here at -6, and our graph is complete. We can label this f of x. We can look back and we can see that that all the conditions are met from the previous steps. The x-intercepts are there, the y-intercept, the end behavior, and even the sign diagram all match the graph.